Hello everyone, I Puneet Upadhyay handling the subject Computer Integrated Manufacturing. In previous session, that is in session 2, we have discussed regarding the feed drive. In feed drive we have studied what is a servo motor, the mechanical transmission system. Then next spindle and spindle bearing. In spindle and spindle bearing, what is hydrodynamic bearing, hydrostatic bearing. Then the measuring system, that is direct measuring system and indirect measuring system. Then what is the gauging? Then at last tool monitoring system, that is direct and indirect tool monitoring system. Then some most important questions for the examination. So in this session we are going to begin with a new chapter, that is Introduction to CIM and Automation, that is a session 3. So in this session what will be covered? What is the CIM? Scope and benefits of CIM, elements of CIM system, automation and types of automation, reasons for automation, automation principle and strategies, 10 strategies for automation production system, basic elements of automation system, levels of automation, then most likely questions for the examination. So now what is a CIM? CIM is nothing but the Computer Integrated Manufacturing, which deals with the integration of product design, process planning, manufacturing by means of complex computer system. So next, the scope and benefits of the CIM. So now we have to study about the scope. So what is the scope? In scope there are basically the three types of scopes of the CIM. First one is the CIM, that is the integration of components from different suppliers. So in this integration of components from different suppliers is that when different machines such as CNC, conveyors and robots are using different communication protocols, in the case of AGVs, even differing lengths of time for charging the batteries may cause the problem. So in this case, the integration of components from different suppliers plays an important role. Next one is the data integrity. So what is this data integrity? The higher the degree of automation, the more critical is the integrity of a data used to control the machines. While the CIM system saves a labor of operating the machine, it requires extra human labor in ensuring that there are proper safeguards for the data signals that are used to control the machines. Last one is the process control. So what is this process control? Computers may be used to assist the human operators of the manufacturing facility, but there must be always component engineer or to handle circumstances which could not be foreseen by the designers of the control softwares. Next one is the benefits of CIM. It improves the operational control, it increases the machine utilization, it reduces inventory, it reduces direct and indirect labor, it reduces the design cost. Next one are the elements of a CIM system. So this is the diagram related to the elements of the CIM system. It has marketing, the product design, the planning, the purchase, the manufacture, the automated work centers, warehousing, finance, information. So these all systems are related to the CIM. Let us study one by one. So what is this marketing department? So marketing department is a need for a product which need to be identified by the marketing division. The specification of the product, the projection of the marketing or the manufacturing quantities and the strategy for marketing the product are also decided by this marketing department. So to identify your product into the market, the marketing department plays an important role. So next one is the product design. The design department of the company establishes the initial database for production of proposed product. In a CIM system, this is accomplished through activities such as geometric modeling and computer aided design while considering the product requirement and concept generated by the creativity of design engineer. Next one is the planning. The planning department takes the database established by the design department and enriches it with the production department, that is production data and information to produce a plan for the production of the product. Next one is the purchase department. Purchase department is a department which is responsible for placing the purchase orders and follow up, ensures quality in the product process of the vendor which receives the item. Next one is the manufacturing engineer. Manufacturing engineer is the activity of carrying out the production of the product involving the further enrichment of database with the performance data and information about the production equipment and process. Sixth one is the factory automation hardware. Factory automation equipment further enriches the database with equipment and process data resident either in the operator or equipment to carry out the production process. Next one is the warehousing. Warehousing is nothing but the area where the storage is done. It is given the specific area for storing of the materials or the finished goods. So in this, the warehousing, the function involves the storage and retrieval of raw materials, components, finished goods as well as the shipment of the items. Next one is the logistics and supply chain management. So in this management deals with the transfer of materials from one place to another place. So whenever the finished product is done with a company, it need to be transferred the finished product to the end users. So this logistic and supply chain management plays an important role. Next one is the finance. Finance deals with the resources, which deals with the money, planning of investment, working capital and cash flow controls. Next one, last one is the information management. Information management is perhaps one of the tasks in a CIM. This involves the master production, scheduling, database management, communication, manufacturing system integration and management information systems. Now next, the automation. So what is automation? Automation is technology which is concerned with application of mechanical, electrical, electronics, computer based systems to operate and control the productions. Basically there are three types of automations. First one is the programmable automation, the fixed automation and the flexible automation. Now let me see the animation video on automation.
Okay, so you've heard of automation or industrial automation a few times here and there, and you're wondering what it is and how it actually works. In this short video that's brought to you by RealPars, you're going to learn what industrial automation is in a very basic and simplified way. Let's get into it. Before we start this video, I have a favor to ask you RealPars fans here on YouTube. If you love our videos, we would love you to go ahead and like this video. This is a great motivator for us to produce free, valuable content for you. That would also help others to more easily find our videos on YouTube. Also, be sure to subscribe to our YouTube channel if you haven't already done so. When you subscribe, each new video will be sent to you as quickly as it is published. Now, let's get into the video. Okay, let's say that I'm entering a room and it's dark. Now, what's the first thing that I should do when entering a dark room? Yes, I should turn the light on. That means I should manually press the switch on the wall and turn the light on. Now, let's say that instead of the wall switch, I'll install a sensor in that room. This sensor has a simple open contact within it, just like a normal switch. The way that this sensor works is that it always looks into the room, and when it sees someone entering the room, the open contact is going to be closed, and following that, the light's going to turn on automatically. When the person leaves the room and there's nobody there, the contact will be open again, and this time the light will be turned off automatically. So by having this sensor installed, I no longer need to press any switch on the wall when I enter or leave the room. With the new system, everything happens automatically on its own, meaning when I enter the room, the sensor kicks the light on automatically. And when I leave the room and there's nobody else in there, the light automatically goes off. Now, if we consider turning on the light in the room a process, we can say that when I need to press the switch on the wall, the process is happening manually. And when the light turns on and off on its own, when someone enters or leaves the room, the process happens automatically. So here, I have manual versus automatic. Now, what's the difference between these two? Well, obviously, the automatic way is more convenient for me, right? Because here, I don't need to press anything on the wall to turn on and off the light. The automatic way is also more energy efficient, because with this method, when I leave the room and nobody else is in there, the sensor is going to turn off the light after a few seconds. With this method, I can expect to see some real energy savings here as well. So this is a very basic example of a manual versus automatic process. Now, let's bring the same concept into a factory, the manual versus automatic concept. When we're going to manufacture a product, there's always a start line and a finish line. The start line is where the raw materials enter into the factory, and the finish line is where the final product is manufactured and ready to be shipped. Between the start and finish lines, there's a process that turns the raw materials into that final finished product. So here, I have a process. The raw materials can be considered as the input for this process, and the final product can be considered as the output, or as the final outcome. Now, just as the process of turning on and off a light, this process of manufacturing a product in a factory can happen either manually or automatically. For the manual process, we can hire a few workers to do the job. But with the automatic way, we can put a system in place that is able to take care of the whole manufacturing process, or at least some parts of it, automatically. For instance, let's say that you're going to start a cupcake business and you want to make your own cupcakes. To make the cupcakes, you'll need a manufacturing process, where all the necessary ingredients come in as the input and a delicious cupcake comes out as the output. Now, at the beginning of your business, when you're on a tight budget and of course have fewer customers, you can hire one or more workers and train them to make the cupcakes based on your recipes. With this limited manual manufacturing process in place, you may be able to make the cupcakes at a reasonable speed and with consistent quality. But as your business grows, trying to make more cupcakes manually with a high consistent quality will be very difficult. Why? Because humans make mistakes. For instance, if one of your coworkers adds more of one ingredient, that batch of cupcakes won't have the same quality as the rest of the cupcakes. And if this happens often, your business will start losing customers and eventually losing money. Now, what should you do to solve this problem? To solve this problem, you'll need to hire an engineering firm to help you turn this manual cupcake manufacturing process into an automatic process. With the new automatic manufacturing process, you're going to have fewer employees and more machinery. This means with the new system in place, your machines are going to take care of most of the jobs that were previously done by the workers, and they're going to do it fast, hassle-free, and accurate. So with the automatic process, you're able to make more cupcakes with the same constant high quality, and this helps your business grow faster. The same principles apply to other industries such as automotive, steel, or oil and gas. For these industries to be able to manufacture the final product based on the new standards, they need to have an up-to-date automatic manufacturing process. So industrial automation is all about large-scale processes with a high degree of quality and consistent accuracy. When we need to manufacture a product on a large scale with consistent quality at the same time, we need to hire an engineering firm to design an automatic manufacturing process for our business or factory.
So let me discuss next the fixed automation. So what is this fixed automation? Fixed automation is a system in which the sequence of processing operation is fixed by the equipment configuration. The operation in the sequence are usually simple. So it is the integration and coordination of many such operations into one piece of equipment that makes the system complex. So it has some typical features for the fixed automation. First one is the high initial investment for custom engineered equipment, high production rate, then relatively inflexible in accommodating product changes. Next one is the programmable automation. So what is this programmable automation? So in the programmable automation, the production equipment is designed with the capability to change the sequence of operation to accommodate different production configuration. The operation sequence is controlled by a program which is self of instructions coded so that system can read and interpret them. The new programs can be prepared and entered into the equipment to produce new products. Some of the features that characterize programmable includes high investment in general purpose equipment, low production rate relative to fixed automation, then flexibility to deal with changes in a production configuration. Next one is the flexible automation. So what is this flexible automation? Flexible automation is an extension of programmable automation. The concept of automation has developed only over the last 15 to 20 years and principles are still evolving. The flexible automated system is one that is capable of producing the variety of products, virtually no time lost for the changeover from one product to the next. So there is no production time lost while reprogramming the system and altering the physical setups. Next one is the reasons for automation. So why we require the automation? First one is the increased productivity. Automation of manufacturing operations hold the promise of increasing the productivity of a labor. This means greater output per hour of a labor input. High cost of labor. The trend in industrialization societies of the world has been towards ever increasing the labor cost. As a result, higher investment in automated equipment has become economically justifiable to replace manual operations. Next one is the labor shortages. In many advanced nations, there has been a general shortage of labor. Labor shortage also stimulate the development of automation as a substitute of the labor. Next, trend of labor towards the service sector. This trend has been especially in the advanced countries. First, around 1986, the proportion of workforce employed in the manufacturing stands at about 20%. In 1947, it is 30%, but by the year 2000, it estimates the figure as low as 2%. Certainly, for automation of production jobs has caused some of the shift. Next one is the safe. By automating the operation and transferring the operator from one active participation to the supervisor level, work is made safer. The safety and physical well-being of a worker has become a national objective with the enactment of the Occupational Safety and Health Act of 1970. Next one is the high cost of raw material. The higher cost of a raw material in manufacturing results in the need for greater efficiency in using this material. The reduction of a scrap is one of the benefits of automation. Seventh one is the improved product quality. Automated operations not only produce parts at a faster rate than do their manual counterparts, but they produce parts with a greater consistency and conformity to quality specifications. Next, reduced manufacturing lead time. For reasons that we shall examine in subsequent chapters, automation allows the manufacturer to reduce the time between customer order and product delivery. Reduction in process inventory. Holding large inventories of work in process represents a significant cost to the manufacturer because it ties up with capital. In process, inventory is of no value. It serves none of the purpose of raw materials, stocks and finished products inventory. High cost of not automating. The significant competitive advantage is gained by automating a manufacturing plant. The advantages cannot be demonstrated on a company's project authorization form. The benefits of automation often shows up in the unexpected way, such as improved quality, higher sales, better labor relations. Next one is the automation principle and strategies. The preceding discussions led us to conclude that automation is not always the right answer for giving production situation. A certain caution and respect must be observed in applying automation technologies. So here approaches for dealing with automation projects, which are there two types: USA principle and 10 strategies for automation and production systems. Now next let us see the 10 strategies for automation and production systems. First one is the specialization of the operations. So in the specialization of operations, the first strategy involves the use of special purpose equipment designed to perform one operation with the greatest possible efficiency. Second one is the combined operation. Production occurs as a sequence of operations. Complex parts may require dozens or even hundreds of processing steps. This is accomplished by the performing more than one operations at given machines, thereby reducing the number of separate machines needed. Third one is the simultaneous operations. A logical extension of the combined operations. In effect, two or more processing operations are being performed simultaneously on the same work part, thus reducing the total processing times. Integration of operations. Integration means combining two or more operations. So in this strategy, the link several workstations together in a single integrated mechanism using automated work handling device to transfer parts between the stations. Increase flexibility. This strategy attempts to achieve maximum utilization of equipment for job shop and medium volume situation by using the same equipment for variety of the parts or products. Sixth one is the improved material handling. A great opportunity for reducing non-productive time exists in the use of automated material handling and sortage systems. Inline inspection. Inspection for quality of work is traditionally performed after the process is completed. This means that any poor quality of product has been already produced by the time it is in inspections. So it reduces the poor quality of the product by regular inspection. Process control and optimization. This includes a wide range of control schemes intended to operate the individual process and associated equipment more efficiently. Plant operation control. Whereas the previous strategy were concerned with the control of individual manufacturing process, this strategy is concerned with the control at a plant level. It attempts to manage and coordinate the aggregate operations in plant more efficiently. Last one is the computer integrated manufacturing, CIM. Taking the previous strategy one level higher, we have integration of factory operations with engineering design and business functions of the firm. CIM involves the extensive use of computer applications, computer database and computer networking throughout the enterprises. So next are the basic elements of the automated system. So this is the block diagram which is related to the basic elements of automated system. It consists of the power, the programmable instructions, the control system and the last one is the process. Now first one, power. An automated system is used to operate some process. A power is required to drive the system as well as to control. The principal source of power is automated system is electricity. Hence, electric power has many advantages, automated as well as the non-automated process. Next, afterwards, it comes to the program of instructions. So, in this, the actions performed in an automated process are defined by the program of instructions. Whether the manufacturing operations involves low, medium, or high productions, each part or product style made in operations requires one or more processing steps that are unique to the style. Next one is the control system. So in this control system, the control elements of the automated system executes the program of instructions. The control system causes the process to accomplish its defined function, which are for purpose it is to carry out some manufacturing operations. So last of this, the process is carried out. So this is the explanation regarding the elements of automated systems. So there are the types of elements. So this is the explanations. Next one, the levels of automations. So this is the block diagram which represents the level of automations. So in this, the level flows from low level to the top level. It has a device level, the machine level, the cell level, the plant level, and the enterprise level. So first, the device level. So this is the lowest level in our automation system. It includes the actuators, the sensors, and other hardware components that comprise the machine level. Next one is the machine level. Hardware at a device level is assembled into the individual machines. Examples include CNC machine tools and similar production equipments, industrial robots, conveyors, and automated guided vehicles. Next one is the cell or system level. This is the manufacturing cell level which operates under instruction from the plant level. Next one is the plant level. This is the factory or production system level. It receives the instructions from corporate information system and translates them into the operational plans for the productions. Last one is the enterprise level. This is the highest level consisting of corporate information system. It is concerned with all the functions necessary to manage the company. Marketing and sales, accounting, design, research, aggregate planning, and master production and scheduling. So these are the levels of automation. So these are the levels. Last, most likely questions for the examinations. So there are total 5 questions which are most likely asked in the examinations. So the students need to look after these questions. Thank you.